Hey everybody! Welcome back to Exploring Electronics. This is episode number 3. In the last episode, we learned mostly about electronic components that are sinks of energy, so components that do things, like lights and motors and all that fun stuff. Let's address our question from the last episode. What types of materials can we use from around the house, or if we're out on the go, to build a resistor? I mean, you never know when a situation is going to strike that will require super important MacGyver skills. It might be life or death, like seriously. Or maybe, hopefully not. But it's always good to know, just in case. So, well, the snarky yet satisfying sciencey answer to that is really technically all types of materials can be made into a resistor. Since we can adjust the dimensions using the equation for resistance, we can figure out what dimensions we would need to make the material to give us the resistance we would want. But some materials, like paper, have huge resistivities, like 1,000,000 or more times higher than copper, which is what we make wires out of. So it's effectively impossible to use them in our circuits because, let's be real, we're not ants. Plus, there are other issues that come into play, like chemical reactions. You don't want to push a bunch of current through a piece of dry paper because it will probably light on fire. Just to show you how to not do this at home, I'm going to show you one way that you can light fire using electricity. So I have this 3D printed circuit thing, or sorry, not circuit thing, but wire holder. I'm going to put a piece of very thin wire in between it. Then I'm going to put a piece of paper over the top of it, and I am going to cover it. Then I'm going to take my power supply, turn my power supply on, and I am going to see what happens. Okay, here we go. Okay. Oh my gosh. Oh my gosh. Ah, that's so cool. Glows red hot, and then it burns right through the paper. So there you go. Like I said, probably don't do that at home. But super cool demo just to show you how we can use current to light a fire. So if you want to get technical, most common modern resistors are made of carbon, metal, or metal oxide film. And we can actually look at a table of resistivities of different materials to figure out what types of materials are useful to build a resistor. So we can check out Wikipedia, we can just Google. I'll use the Wikipedia table since it's open source and Wikipedia is a great website. So we can look at this table and figure out what objects around the house have materials with resistivities between carbon, which is what most resistors are made out of, amorphous carbon, and copper. We want something in between those, ideally. Oh, hey look! We noticed that there's Mr. Lead in the middle. Pencil lead. What? Well, okay, wait. Pencil lead is really graphite these days since, you know, lead poisoning and all that. That's pretty bad. But hey, graphite still works. Look at our table. So heck yes, that means we can friggin' draw a resistor. What? Yes, for real. So grab a piece of paper and a regular number 2 pencil, or honestly, any friggin' pencil should work. I mean, seriously, we're having way more fun than the Scantrons are having. So once you have that, draw a solid line on the paper about 1 inch long, and then draw over it a few times. Make sure it's totally filled in and doesn't have any gaps. Okay, so once you have drawn your line, you can grab a 9-volt battery clip, or a couple of paper clips, and an LED, and then we can connect our LED to the 9-volt. Okay, so if we do that, it lights up, yay! All right, we just prevented our LED from burning out. That's so cool. Definitely be very careful not to short the LED because I burned through a lot of these. It only takes a split second for it to burn out. All right, so that's awesome. Now we know how to make a resistor so we don't burn out our LED with our 9-volt that we definitely did not pull out from the smoke detector. So what if we want to calculate how much our line or our resistor is helping? Or, you know, what if we want to make our LED brighter or dimmer or make our battery last longer? Well, what can we do about that? So the easiest way to do that would be to just measure the resistance of your line using a multimeter. So go ahead and do that if you have a multimeter on hand. If not, we can use a rough estimate of about 100 kiloohms. I measured this earlier, so if you drew a 1-inch line, that should be about what it is. And so now we can figure out the circuit current running through our LED using the following equation, where we get 9 volts divided by 100 kiloohms, which equals about 0.09 milliamps. And so we can increase the current flow if we use a shorter line, which I will do like this. So you can also check it by just moving the wire closer to the LED, and voila, our LED just got brighter. It's so cool. So, you know, like I said, just be careful it doesn't get too short or the LED will definitely burn out, which is sad. So yeah, that's pretty much it. So let's end with some technical stuff so that we can be on the same page as those electrical engineers and also with each other. So when we want to talk about or share ideas, it's helpful that we use the same terminology. It also makes conversations and sharing ideas a lot faster. So, okay, technical stuff, no problem. We understand it. We can handle it. So first of all, resistors have 2 terminals, one connection on each end of the resistor. When modeled on a schematic or a drawing of a circuit, a resistor will show up as one of these 2 symbols. The terminals of the resistor are each of the lines extending from the squiggle or the rectangle. And those are what connect to the rest of the circuit and to different circuit components. Okay, so what happens if our resistor is all lonely and wants another resistor buddy? So resistors might be stubborn, but they do follow some rules. So if you add them in series, they add pretty normally. Each individual resistor will add together just like this. So you just sum each individual one, and then that is your total circuit resistance. However, it gets a little tricky when you're talking about resistors in parallel. So resistors in parallel add together like this. Don't get too worried. You can totally handle it. It's just a little bit of algebra. Basically, you just want to add 1 over each of the resistors, sum those together, and then divide that total by 1 over that total to get your total circuit resistance. So this might be to keep us on our toes a little bit. Electricity is kind of confusing sometimes, but it can actually be pretty useful since you can adjust the resistance of your circuit just by changing how you connect the resistors together, which is super awesome. So the beauty of science is that it allows us to be lazy and cheap. Yes! So yeah, that's awesome. We're totally into circuits now. We know about Ohm's awesome law, that voltage equals current times resistance. It can be a little tricky to use with complex circuits, so let's keep an eye on that in future episodes. We also know how to build our own friggin' resistor at home with a piece of paper and some pencils, or a pencil probably. And we can also adjust our circuit resistance by adding resistors together in different types of combinations. So that's it. Thanks a ton for watching, and go forth and explore the world of electricity and different electronic components. Oh, it broke. I don't think the candle's gonna work.